Okay, so looking here at section B, we're going to actually look at the center, and really we need to consider what is an average. You know, we throw that term out a lot, but the word average really could mean one of three things. In its true definition, an average is just a measure of the center, or the central tendency, we could say. The mode, the median, and the mean all measure the center of data. Okay? So they do it in different ways, and the real difference is in how we're defining center. Okay? Now, when we say average, and I do it too, so when we say average, we almost always are talking about mean. Okay? The arithmetic mean. But we do need to make sure we understand our terminology properly. So let's start real quickly by just talking about the mode. And we already kind of ran into this concept in the practice that you guys just did. Let me get this stretched out. There we go. Okay. The mode is the most frequently occurring value in a set of data. Okay. Now the data does need to be discrete. Okay. In other words, there have to be exact measurements. It's possible to have more than one mode. We could have bimodal data. If you look at this data here that's listed, 17, 18, 18, 19, 20, and so on, what would our mode be?
185 and 192.
Or no, on this data here.
27.
The 27. There's 3 27s. There's only 2 25s, 2 26s, and some others. But there are 3 27s, so we would say that's the mode. If we're dealing with continuous data, dividing it into classes gives us that sense of having discrete data. Okay? Even though it's still technically continuous, we can talk about a modal class, like you guys just saw. And the reason why we talk about modal classes is right here. The likelihood of having any data elements that are exactly the same is very low. Okay? Even if you were talking about, say, income levels. Okay? You make the exact same number of dollars and cents as somebody else, it's very unlikely. Okay? You know, if you're measuring the length of something, especially recognizing that the tools that we have to measure with are not precise. So we use classes, and here we have heights of things set up, and the modal class was 11, as you guys saw, because that range of data from 185 up to just under 190 centimeters occurred the most often. Okay, so that's our mode and our modal class. The median we're going to use quite a bit. The median is the middle score. Okay, now one important thing when we're dealing with the median is that we need to make sure we put the scores in order from smallest to largest. Okay, the middle score is the median. Okay, if you drive down the highway, those big concrete things in the middle of the road, that's the median, okay? Or the grass too. That's the median. It's in the middle. So for example, here we have that same data. The middle score, okay? We're going to count, how many are there here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. So the middle score would be which one? If there are 19 pieces of data in this first set.
The 9th one. No, this is the 10th one.
The 10th one. Easy way to do it is divide and round up. Okay, so 19 divided by 2 is 9.5, so it'll be the 10th score that's in the middle. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 23 would be our middle score. That's our median. Okay? If we have an even number of scores, okay, here we had, and I'll use the notation n we usually use for the number of elements. N is 19. Here we have n equal to 20. We added another score. So we get the average of the two middle ones. If it comes out evenly when you divide by 2, it came out to 10. Okay, that means you have 10 on either side of the median. So you need to average or find the mean of the two middle scores. All right, so here is the 10th score, 23. The 11th score is 24. So our median would be 23.5. Okay? Again, this is somewhat a review from last year, but I want to bring it back to memory. Okay? Any questions so far? All right. Now, the arithmetic mean. This is something that you've done forever. Okay? Add them all up, divide by however many you had. The one thing you do need to note, though, is a little bit of notation in the formulas, okay? The formula, notice we have sigma notation, the sum from I equals 1 to n of the x sub i's, all over n, okay? Now, notice here we have this notation and we have this notation, okay? The x bar is how we would read that first one. X bar. That's the mean of the values of x. Okay? That's the mean for a sample of data. Okay? By the way, when you do your IAs, make sure that if you are talking about a sample of data, like if you do something for, you surveyed half of the senior class or 10% of the senior class. That's a sample. You're going to use X bar if you're talking about a mean. However, if you actually survey every member of the senior class, you've got the whole population there. Okay? And in that case, you're going to use this symbol here. That's the Greek letter mu. Okay? Could draw it like that. Okay? In general, Greek letters are population, other letters, Arabic letters, or English letters are for a sample. Okay? You'll see that again when we get to standard deviation and variance. Okay? So now, if we were finding the mean of all of these, we already know that n is 19. So what would we do with all this data? Add it up and put it over 19. Okay? We won't take the time to do that because like I said, you guys have done this for a while, but we need to make sure we understand the notation. Would we do anything different if we were told this was a sample? As opposed to if we were told this was the population? No. It's the same formula, it's just making sure you use proper notation to communicate what you're dealing with. Alright, so we've talked about our mean, median, and mode. So now let's talk about distribution. Alright? And this is where it's helpful to see different distributions, okay? You can see here the different colors, and we have a negatively skewed set of data, we have a bell-shaped curve, or we would call this symmetric. We might also say it's normally distributed, okay? And then we have positively skewed data. The negative and positive can be a little bit tricky because your initial thought is going to be to switch them, okay? Here, it's all in how the mean and median and mode relate to each other, okay? On any of these distributions, the highest point is going to be your mode, okay? Now, these are frequency distributions, okay? So this is how often these occur. So this value doesn't occur very often. This value occurs the most, okay? So the mode will always be the highest point. The mean, we just said, it can be kind of wherever. And the median will be at the point where half of the data is below and half of it's above, okay? The skewing occurs when, for example, here we have a number of negative values, very low negative values. And those I shouldn't say negative values, we have a number of very low values. And what they've done is they have pulled the mean lower than where the majority of the data is centered around. So we would say that it's skewed negative. This would be like if we had, the class took a test and, almost everyone got, A's or B's or whatever, and then we had a couple people get, we had 2 people get an F. That would negatively skew the class data, all right? Likewise, we could have a test where everyone really, really struggled and then we had 2 people who aced it, okay? You've got them up here and they have positively skewed the data. They've pushed the mean higher than what is really representative of the whole of the data, okay? Now, what this leads to is, this is why we have 3 different ways to measure center, okay? Because the mean can very easily get skewed by extreme values. However, if we consider the center in the median as being the middle value, that might be a better representation of our data. In fact, if you look at a lot of government statistics, particularly when it comes to income or things like that, they'll talk about the median or ages even. What's the median age for someone who's incarcerated or something like that. Median income is a big one, or median home prices. There's only so little you can make, okay? But the ceiling as far as how much you can make is unlimited, So it's very easy, let's say you're talking about the mean income of some city, you could have 3/4 of the population in poverty, but if you have a few multimillionaires living there too, it's going to really skew your mean. So if you use the median, that might give you a better representation of what the population is really like. Same thing with with income, same thing with like home prices. There's only so cheap you can build a home, even if it's a dump. The land itself is worth something. But then you have these really opulent homes that cost millions and millions of dollars. It wouldn't be accurate to find a mean value. You would want probably a median to give you a better representation, okay? So again, that's where the median or possibly the mode might be more useful than others. Okay, here's an example. This is my last year teaching at my old school, my Algebra 2 class. This was like the distribution for most of my tests. Okay, because I had some really, really bright students. It was a real small school, so all the sophomores took Algebra 2, period. And there were only 13 of them. Okay, so I had 6 who were really, really good and would basically always get an A. And I had 3 who had mild to moderate learning disabilities and almost always failed. So finding an average or finding the mean score on the test told me absolutely nothing about how they really did. Okay, finding the median though was actually helpful. Okay, the mean was a C, but the median here was a B. So I knew, okay, 50% of the class is getting A's or B's. The other 50% we need to work on, help them out a little. But in that case, the median was a much more useful measurement. Okay? So, even though the mean is the most commonly used probably, or the most familiar to us, I should say, it's not always the best one to use. Okay? All right, now, one thing that can get a little bit tricky is when we throw into the mix frequencies. All right? And using a frequency table, we'll cover some of this up. We have our data, and we have the frequency for each element of data. So X occurred once, 3 occurred once, 4 occurred once, 5 occurred 3 times, 6 occurred 7 times, 7 occurred 15 times, 8 times, and 9 5 times, for a total of 40 different pieces of data that we have. Okay? One of the most common mistakes students will make is they'll just add up 3 through 9 and divide by 40. Okay? But they're forgetting that there isn't just one 7 there. There's actually 15 different 7s. And if we were to list them all out, to actually do the formula for mean, we'd be doing 3 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6. Look, I'm multiplying now. And so on. And that gets really tedious. So instead, we use these frequencies. And we simply multiply the data value times its frequency to give us what all of the 7s equal. All of the 7s add up to 105. All of the 9s add up to 45. Then we can add those values. 3 plus 4 plus 15 plus 42 plus 105 plus 64 plus 45 is 278. That is really adding all of them up. We divide that by 40 and we can get our mean. So we aren't told if this is a population or sample, so we'll assume it's a sample. Okay, 278 divided by 40, okay, and we get our mean. Our mean would be, let's see, that goes in, 6 times 6 and 38/40ths. Okay, so that's 19/20ths, which would be 6.95. Okay, so there's our mean, 6.95. Notice what we did here. This whole formula here, and by the way, this is a formula that's in your IB formula book, so you need to be familiar with the notation there. It's the sum of the scores times their frequencies divided by the sum of the frequencies. Okay? The sum of the frequencies just tells us how many scores there are total. Okay. Is that making sense? Okay. Alright. One other thing while we're here, that's the mean. The mode when you're given a frequency table is easy. What's the mode here? 7. Okay, 7's the mode. The median is the one that can be a hair tricky. What score are we looking for when we find the median?
The middle.
The middle. And since we have 40 pieces of data, which score are we going to look at?
21st.
Well, we're gonna look
Going
into
to-
the 8th and 21st.
Okay, yeah, the 20th and the 21st, and we're going to find the mean of those. So this is where utilizing what's known as cumulative frequency. Okay, cumulative frequency can be helpful. So we had 1, 3. There was 1, 4 as well. So now we have a total of 2. There were 3 5s. So that means we have a total of 5 pieces of data. And really what this does is tell us how many are that or below. Right? There's 5 pieces of data that are a 5 or below. And then there are 7 that are 6s, so add that, and now we have 12 that are either 6 or below. And then 15 7, so that's 27. Okay? And then add the 8, we get 35, and add the 5, and we get the 40. And this ought to match that number there. Okay? But we need the 20th and the 21st score. They're both 7s though, right? Okay, so the 20th and the 21st score are both 7. Oops. Okay, therefore the median is 7. Okay? So that's how we can work with a frequency table. And that also gives us then the idea of the cumulative frequency. Alright? Alright, so okay, good. It's right on time. One thing I want to mention here, I have we did some practice here in class, and but I do have a few for you to try that are kind of, these aren't just standard, find the mean of this data, find the mode of this data, okay? You're not really gonna have questions like that on the IB exam, okay? A lot of what the IB exam will do is kind of take what you've already learned and twist it a little bit. Okay, for example, here they give you the mean, they give you how many scores they are. They want, hey, what's the sum of all the scores? So you're going to have to use the formula.
Can I just write it down?
Yeah, now this is actually, so you guys know, this is actually posted on the class website. Okay?
Alright.
So you can go there, it's listed there. The other thing I will say, with the new retake policy this year, retakes are available, but you have to fill out the form, and also I will give you a list of things on the back of that form that you will need to do. One thing I will guarantee you I will have on every one is you show me all the homework done. So, number one, do the homework, but also hold on to it. Label it so you know what section it goes with, and hang on to it. So if for some reason you do end up needing to do a retake or something, you have that, and you don't have to go back and redo problems that you've done in the past in order to qualify to take the retake. Okay? Alright. Good work today, guys. Have a great day, and we'll see ya.
Just like last year.